Good morning everyone. Today we are going to discuss about the fundamental principles governing metal finishing. Since the process of electroplating essentially involves electrolysis, the three important factors governing the process of metal finishing are namely polarization, decomposition potential and overvoltage. We'll see the first one, which is called as polarization, and it is defined as the process where there is a variation of electrode potential due to inadequate supply of ions from the bulk of the solution to the electrode. Polarization is an electrode phenomenon, hence the electrode potential can be determined using Nernst equation E is equal to E naught plus 0.059 over n log of Mn plus. As you know, where Mn plus is the concentration of metal ions surrounding the electrode surface at equilibrium. When there is a passage of current, the metal ion concentration near the electrode surface decreases due to the reduction of metal ions. Hence, there is a shift in the equilibrium and a change in the electrode potential. This leads to diffusion of ions from the bulk of the solution towards the electrode surface. This re-establishes the equilibrium, as if the diffusion is slow, the electrode potential changes and the electrode is said to be polarized. Following are the some of the factors which are responsible for variation of electrode potential. The first one is distance between the electrodes, concentration of the electrolyte, temperature of the reaction, materials used as anode and cathode. Now we'll see the second one, which is named as decomposition potential, and it is defined as the minimum external voltage that must be applied in order to bring the electrolysis of an electrolyte. Decomposition potential is represented by symbol ED, and it can be determined by the graphical method, that is current versus potential. You can see the second picture in this slide, which shows the graphical representation, that is current versus potential. And if you see the first diagram here, it can be determined using an electrolytic cell which consists of two platinum electrodes immersed in a dilute solution of an acid or a base. When the voltage is varied, at low voltage no reaction occurs, and therefore there is a slight increase in the current. On increasing the voltage to slightly above 1.7 volt, there is an abrupt increase in the current. The applied voltage of 1.7 volt is the decomposition potential for dilute acids or bases. Did you understood the minimum external potential that must be applied in order to bring the electrolysis of an electrolyte is called as decomposition potential. Now, significance of decomposition potential is, if you have the knowledge of decomposition potential, which will help us to find out the potential required for the electrolysis. Now following are the some of the factors. Decomposition potential is always different for different electrolytes, and it depends on temperature of the reaction, concentration of the electrolyte, current strength, and also on the nature of the electrode and electrolysis products. Now the last one is called as over voltage. Sometimes it is also named as over potential. Over voltage is defined as the excess voltage that has to be applied above the theoretical decomposition potential for a continuous electrolysis, and it is represented by symbol eta, which is nothing but experimental decomposition potential minus theoretical decomposition potential. For carrying out continuous electrolysis process, the applied voltage should be greater than back EMF. It is observed in few cases that electrolysis does not occur unless potential greater than theoretically determined decomposition potential is applied. For example, for electrolysis of dilute sulfuric acid, the required potential is 1.7 volt, but theoretically determined potential is 1.23 volt. When you subtract 1.7 minus 1.23, you are going to get an answer of 0.47 volt, which is nothing but a over voltage for dilute sulfuric acid. Following are the some of the factors which are affecting over voltage. They are electrode surface, temperature of the reaction, current density, electrode potential, rate of stirring. Thank you.